So in this problem, in problem 5 from Precept 10 in spring 2020, what we want to do is we want to check whether a model that we train on the Titanic data set satisfies calibration. Okay. So we want to first display the bar plot that shows the probability of actually being positive for each decile score. And then we also want to display the confidence interval that's associated with it using geom error bar. So here's how to do it. So this was like a challenge question. Obviously, like I'm not going to ask you to do error bars because we have not done them in lecture. So we read this. So then what we do, although kind of other stuff might be relevant, right? So then what we do is we say, okay, so we'll group by decile and sex. So we do that in order to compute the probability of actually dying if the model predicted that you died, or actually living if the model predicted that you lived, for like males, for males decile 1, males decile 2, females decile 5, males decile 5, and so on. So for each of those groups. Okay, so we compute the mean of survived. So that's the survival rate. And we also need the total number of people there because we need the sample size. And we need the total number of people in general. So what row-wise does, it's like a convenient thing to do. You could have done it in a different way as well. So you would need to use SML201. So what row-wise does is it basically processes the data frame row by row. So let me show you. So this is just like this. So right now, Titanic serve is like this, right? So we have the rate, we have the total, and we have the n. And next we do row-wise and mutate. So, right. So we do row-wise and then we do mutate. So what I'm trying to do is I'm trying to kind of just process this row and then just process this row and just process this row and just process this row and so on. And what we're doing here is we're getting the confidence interval for, so we're getting the confidence interval for, so for the survivor rate, and binom test actually provides that. So we know how to compute the confidence intervals otherwise as well, but SERVMIN actually provides that as well. So what we're doing is we're saying we're giving it the total number of survived, we're giving it the total number of people, so the total number of males with 0 decile, and we're giving it the p, and from that we can get the lower bound of the confidence interval and the upper bound of the confidence interval. So without row-wise, it would be like we're operating, when we're saying serve total, it's like all of this column, and binom test just doesn't work that way. It needs just the one number. So row-wise ensures that it's as if we're just talking about decile equals 0, sex equals male, serve equals 0, serve rates are equals 0.04, and so on. And then you process this row, and then this row, and then this row. Because without that, you would, like, this would be the whole column, this would be the whole column, this would be the whole column, and kind of binom test just doesn't do that. It needs this to be a number, and this to be a number, and so on. Okay. So that this gives us the confidence intervals. So we can look at what that looks like. So we have kind of the lower bound and the upper bound of the 95% confidence interval. So because we did row-wise, we now want to ungroup, and we just want to remove all of the entries with the zeros because they won't display nicely. So so here they are removed actually, for some reason, but we don't want any rows with n equals 0. So that's what the next bit of it does. So we just filter. Oops. So Titanic Serve now looks like this. Okay, so what this says is essentially like if we want to estimate the probability of survival for females with decile 3. So decile 3 means like the predicted probability is like between 30 and 40%, right? So here it's very wide. So because there's just two of those people, it's very wide. So it could be like anywhere between 1% and 99% essentially. So the confidence interval here is a little bit less wide because there is 68 people. Okay. So we then display it using the error bars. So it looks like this. So what does calibration mean? Calibration means that the predicted probabilities mean the same thing for, in this case, the different genders. So it means that if for a woman, kind of the output is 60% probability of survival, it should mean the same thing as for a man. So in practice, what it should be is that for third decile females, third decile males, it should be the same. This is actually males, this is females. It should be the same, the probability of surviving. The probability of surviving for the 7th decile should also be the same. Now, what you see is the confidence intervals here are so wide that you can never actually tell that the columns are genuinely different, and it's not just like an accident that they look different. However, it kind of seems suggestive. It seems suggestive of the fact that maybe there is not necessarily calibration. So one thing we could do in order to make it calibrated is to use sex as a predictor. So, okay, so I used sex here as well, which I shouldn't have done. So I'll fix that in the solutions. So the idea was not to use sex here and then to use sex here. So yeah, and we got exactly the same thing. So why is it that you might expect that there would be calibration if you do include sex, but you might expect that there is not calibration if you do not include sex? So the idea is like this. If you're just looking at age at P class, right, then because we know that females survive at a higher rate, you might expect that for the same age, for same P classes, you'll underpredict the probability of survival for women and you'd overpredict it for men if you are not using sex as a predictor. So that would be the reason that you'd expect that there might not be calibration if you don't use the sex as a predictor. I'll rework the example and post it in a second.